Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Laulu and I'll be walking you through the chemistry course. In this particular lesson, we'll be considering the acids, bases, and salts, and we'll look at the topic, the acid, and we'll talk about the basicity of the acid. We'll look at the properties of the acid as the physical and the chemical properties of the acid. We'll talk about bases and alkalis, differentiate between them. We'll talk about neutralization process, then we'll look at the properties of a base, those are physical and chemical properties as well. Then we'll talk about the measurement of acidity of base or alkalinity of a substance, and we'll move to salts and the types. Talk about the preparation of salts, water of crystallization, efflorescence, the liquescence, and hygroscopy. Or the efflorescent, the deliquescent, and the hygroscopic compounds or substances. Then we'll look at ionic reactions and equation and conclude the lesson with conductance of acids, bases, and salts. Alright, let's go to the topic. Acids. What are acids? An acid is defined as a substance which, when dissolved in water, produces hydrogen ion or hydrozonium ion as the only positively charged ion in it. So, acids, basically, it produces hydrogen ion or hydrozonium ion. Now, hydrozonium ion is simply hydrogen ion reacted with the water. Of course, for an acid to display its properties, it has to be diluted in water. Acids are generally formed from acid anhydrides. Acid anhydrides, and these acid anhydrides are compounds which most of them are gases. They are compounds in which you burn something and it forms an acidic substance. So when you dissolve your acid anhydride in water, you get your acid. That's why it's called the anhydride. When it says something is anhydrous, it means it contains no water. So some examples of acids that we do know, we have the HCl, we have the H2SO4, we have the H3PO4, we have H2SO3, we have H2CO3, and many more. Of course, we have HF. So just to mention some of their acids. Now, this hydrochloric acid, this tetraoxosulfate 6 acid, this is tetraoxophosphate 5 acid, and this is trioxosulfate 4 acid and trioxocarbonate 4 acid, just to mention the name of those particular compounds. Let's talk about the basicity of an acid. The basicity of an acid. When we talk about the basicity of an acid, we are talking about the number of hydrogen ion that is possible to be liberated from the acid when it is reacted in a chemical reaction. In the case of the let's take a look at all the acids we've written on the board. We have HCl, that's hydrochloric acid. It has a basicity of 1 because it has only one hydrogen atom that can be liberated from the system. We have tetraoxosulfate 6 acid, which has a basicity of 2. It has 2 hydrogen atoms that can be liberated. We have tetraoxophosphate 5 acid, which has a basicity of 3 because it has 3 hydrogen atoms that can be liberated. We also have other acids such as ethanoic acid, methanoic acid, and the rest of them. They are these acids generally are organic compounds. They are organic acids. We have very many types of acids. We have the lactic acid. Talking about organic acids now, naturally existing. Lactic acid, which can be found in milk. We have the citric acids, which are found in fruits, in vitamin C producing fruits. Amino acids found as end product of proteins. Fatty acids found as end products of fats and oils. Now this acid, this particular one, is 2 O's. HCHOO is completely wrongly written. C2H5COOH. That's the acid. Yes, C2H5COOH. This particular acid has just one releasable hydrogen ion, which is this particular ion, hydrogen atom rather, which is this particular hydrogen atom at the end of the entire formula. It is an organic acid, and of course, let's go. So basicity of the acid talks about the number of hydrogens that can be liberated from the particular acid. All right. And before we proceed further in this particular lesson, let's take a quick break. In this break, we'll test your knowledge of what has been taught in this lesson so far. Some questions will be displayed on your screen. Please attempt them, and let's have a feedback from you. Thank you. All right, let's talk about. Welcome back. Before we went on this short break, we talked about acid and basicity of an acid. So let's go on to talk about the properties of an acid. We have two sets of properties of acids. The first sets are the physical properties of acids, while the other ones are the chemical properties of acids. So, what are the physical properties of acids? What are those physical things you can observe about them? First and foremost, you can observe that acids in their diluted state, of course, when those edible ones, when you put them in your mouth, they have sour tastes. They are sour tasting in their dilute state. So that's one of the physical evidence. Of course, when you take your fruit, your orange, which contains citric acid, it's in your mouth, it has a sour taste. Yes, also acids generally turn blue litmus red. So you take if you have a blue litmus paper, you put it on an acid, it will turn to red. If you have a red litmus paper and you put it on an acid, it will remain red. So that's what acids do. They turn blue litmus paper red. And also, concentrated acids are corrosive. Concentrated acids are very, very corrosive. This is the reason why in the laboratory we are always told not to add water to acid in the process of trying to dilute the acid. Rather, you should put the water in the beaker, then add the acid to the water. When you try to add water to acid, there is a possibility of the acid splashing out and splashing over your body. That can be very, very harmful. Alright, what are chemical properties of acids? Chemical properties of acids talk about the ways we observe them. We talk about the first one is reaction with metals. Acids generally react with metals to liberate hydrogen. I'll use hydrochloric acid as my example. When we react hydrochloric acid with a metal like iron, or let me use magnesium. Of course, 2 molecules of hydrochloric acid react with 1 molecule of magnesium to produce a salt, MgCl2, and liberates hydrogen gas. Hydrogen gas would be liberated. When you react hydrochloric acid with metals, hydrogen gas is liberated. When you react acids with bases, it produces an HCl plus H2O. It produces salt and water. When you react an acid with a base, this is with metal, with a base. What about trioxocarbonate? Let me just use carbonates. Trioxocarbonate, we react HCl plus calcium. Let me use calcium. Calcium trioxocarbonate 4. You conduct this reaction, there will be the production of calcium chloride plus, of course, you need 2 molecules of this plus water, plus CO2. Now, when you react acids with trioxocarbonate, you have a release of the carbon dioxide gas. The carbon dioxide gas is liberated. So these are the chemical properties of acids. In the laboratory, we have different methods for producing acids. Most acids are produced from their acidic anhydrides. So, which means either you burn a particular substance in air for it to become anhydrous, and then you mix it with water. Of course, the unique one is the hydrochloric acid. The hydrochloric acid. Hydrochloric acid is produced by bubbling hydrogen chloride gas through water. Bubbling hydrogen chloride gas through water, and you would have your hydrochloric acid. Of course, to prepare our H2SO4, that's our trioxosulfate 6 acid, you react your sulfur 4 oxide, react it with water. Sulfur 4 oxide reacted with water, it will give us our trioxosulfate 4 acid. And also, if you can get a means to produce sulfur 6 oxide, sulfur 6 oxide, and you also bubble it through water, you can also produce tetraoxosulfate 6 acid. Of course, let's talk about bases and alkalis. So what is a base? Before we go to alkali, what is a base? A base is a substance which, when dissolved in water, when it ionizes in water, to produce hydroxyl ion. The hydroxyl ion is OH minus. Hydroxyl ion, and that is the only negative ion it produces. It produces hydroxyl ion as its only negative ion. So, what happens if you have a particular compound, NaOH? When you ionize this in water, it will liberate. When you dissolve it in water and it ionizes, you have Na plus minus, just the same way you have in your HCl, that it will have ionized in water. When it ionizes, it will give you this plus Cl, or when you react it with water before you ionize, it will give you H3O plus Cl minus. So in this particular one, when we're talking about bases, the hydroxyl ion is the only negative ion, unlike the acids where the hydrogen ion or the hydrozonium ion is the only positive ion. So what is an alkali? An alkali is simply a base that is soluble in water. That's all. An alkali is a base that is soluble in water, which means you add an alkali to water, it dissolves naturally. Alkalis usually come from the group 1s and group 2 elements. The group 1 and the group 2 elements are the ones that usually form our alkalis. We have many of them. We have You have lithium hydroxide, all of them like that, LiOH, NaOH, potassium hydroxide, and all these substances, very, very interesting substances. Okay, what do we mean when we talk about neutralization? Neutralization is a chemical reaction that involves an acid and a base in the production of salt and water. Neutralization is a reaction which involves an acid and a base, which results in the production of salt and water. Some other scientists do choose to describe neutralization as a chemical reaction between the hydrogen ion of an acid and the hydroxyl ion of a base to produce salt and to produce water. Is a reaction between the hydrogen ion of an acid and the hydroxyl ion of a base to produce water. So let's talk about the properties of a base. The properties of a base, of course, can distribute the properties of a base just the way we distributed the properties of an acid into two: the physical properties and the chemical properties. Let's start with the physical properties. Well, food substances which are basic, when we taste them, they have bitter tastes. Food substances that are basic, or even other substances which are basic, if you have a dilute base, when you taste it, it has a bitter taste. Apart from the bitter taste, it also has a soapy feeling. When you touch it, it feels soapy, slippery somehow. Also, the base turns red litmus blue, be it concentrated or dilute. It turns red litmus blue, and it also lets blue litmus remain blue. So it turns litmus blue when they are inserted in it. Also, concentrated bases are equally corrosive. Concentrated bases are equally corrosive. A very good example is what we know as our caustic soda. The caustic soda, which is used in soap making, is very, very, very dangerous. In fact, that's why some of the soap we buy in the market, especially our detergents, when we use them, you notice that your hand begins to fade, take some colors. Some of us do actually react to it. The fingers begin to peel. It is because of the base contained in it. If the caustic soda proportion added is excessive, it causes all of these things. Okay, let's talk about the measurement of acidity or alkalinity of a substance. What do we mean by acidity? What do we mean by alkalinity? When we're talking about the acidity of a compound, it means that how acidic is it? To what level is the acid strong? Also, when we talk about alkalinity, it means that how basic is it? To what level is the base effective? Well, we have a scale, which is the pH scale, that is used for measuring acidity and alkalinity. The pH scale is graded 0 to 14. 0 to 14 with a midpoint of 7. The midpoint 7 indicates the neutral point of the system, of the balance, where it is neither acidic nor basic. While 14 represents strong alkalinity, whilst 14 represents strong alkalinity, 0 represents strong acidity. It represents strong acidity. So the lower the pH value, the stronger the acid. The higher the pH value, the stronger the base. Yes, earlier I mentioned that there is also there are two types of properties of bases. That's the physical properties and the chemical properties. So let's talk about the chemical properties of bases. Chemical properties of bases, the first thing to mention the first thing to mention is the fact that bases react with acids. That's we have NaOH plus HCl, like I wrote the other time. It will give NaCl plus H2O. They react with acids to produce salt and water. They also react with ammonium salts. Ammonium salts generally are they can sublime naturally, so it produces they react with ammonium salts to liberate the ammonia gas. Of course, they produce salt and water, then liberate the ammonia gas. So let's continue. Let's consider what what salts are and their types. A salt is a chemical compound which is an output produced of a reaction between an acid and a base. It is produced by having a kind of ionic bond between a strong or within a metal and a non-metal. Of course, the non-metal oftentimes is not it might be a compound, so it has the positive charge and also has the negative charge, kind of very balanced within its system. We have different types of salts. We have the normal salts. Normal salts are salts that are actually normal. They behave the way they ought to behave. They do not have any strange or odd thing in their structure. So, and a very good example of a normal salt is cooking salts, as sodium chloride. We can also have salts like magnesium nitrates. Magnesium nitrate is also a normal salt. The thing to notice, they are singular salts and they are complete in themselves. We also have what we describe as the acid salts or the acidic salts. Acid salts or acidic salts. In the case of acid salts, these salts still have a function of the acid in them. In other words, they are not completely converted to salts. A good example of an acid salt would be sodium hydrogen trioxosulfate 4. You see the H function still popping up in the equation to show us that it is an acid salt. See the H function in the particular formula of the acid. Of course, if you react this acid one more time, this particular salt, if you allow this particular salt to take part in a chemical reaction, it will still produce more water out of this. So that's one of the things. It can still react and act like an acid. We also have the ones we describe as the basic salts. That is the basic salts that are all basic in nature. In basic salts, we have examples such as zinc chloride. Yeah, you see the OH function in the formula. The OH function in the formula. We see the OH function in the formula. The OH function there, which means that if this salt is allowed to react with an acid, it can still act as a base. It can still act as a base. We have some salts that we do declare as double salts. Double salts. Double salts are unique styles of salts such that they have the functions of two different substances combining to form one salt. They have two different substances, as in three different substances rather. That is two different we have two different positive or two different negative forming one salt, like we do have in the case of sodium, potassium sulfate. In this particular case, we see potassium, which is supposed to form a salt with triazosulfate. We see sodium also, which is supposed to form a salt with triazosulfate, and both of them are coming together for trying to make one salt. This is described as a double salt. We also have the ones we describe as complex salts. Complex salts. In complex salts, example. Complex salts contain several complex charged substances in them. They have charged substances in them, which when you ionize it in water, it just gives you lots of charges. So we describe them as complex salts. They are quite difficult to handle. We have a few of them. The complex salts, we have a very good example as the potassium ion cyanide. If you see, this particular combination is a little bit technical. When you try to work around it, you might actually get it mixed up. If you try to, when it is ionized, you see the potassium come out separate, and you see the ion merging with the rest of the expression to get us a negative valency. This shows the complexity of the particular expression. So these salts, most of these salts are non-stable. They decompose in nature. Alright, so these are the different types of salts that we have. Let's talk about preparation of salts. Generally, salts are prepared in laboratory by neutralization. That's a chemical reaction between an acid and a base. Chemical reaction between an acid and a base, such as you have sodium hydroxide plus triazonitrates 5 acid, and when you react them together, you have NaNO3 plus H2O. So this is production of a salt. Now this is a base, this is an acid, this is a salt, and then we have the water. So this is the laboratory method with which we produce salts. But also another method for producing salts industrially, since we know very well that salt water is very abundant in seas. Salt water is very abundant in seas. So certain people do get sea water and do vaporize or evaporate it to get salt out of it. Also, salts can be found in certain minerals. These minerals, you find them in earth's crust. So when you see these minerals, they are blended and processed for use. Okay, let's talk about water of crystallization. From the name, water of crystallization, that's water that helps the substance to crystallize out. It helps it to remain in its crystalline form. Now, water of crystallization talks about water that a particular substance might absorb or retain to retain its crystalline structure. When it loses this water, the crystalline structure is lost and the substance becomes amorphous. Of course, what do we mean when we talk about something being crystalline? It means it has shape, a needle-like shape, or it has a definite shape. But when it becomes amorphous, it means it becomes shapeless. So this particular salt we have on the board, copper copper tetraoxosulfate 6 salt. It is it needs 5 molecules of water. 5 molecules of water to retain its crystalline state. Now, this molecule of water is loosely bound to the salt, such that with just a little heat, you can break the relationship between them and you can vaporize the water. But once you vaporize the water, the salt will no longer be in its crystalline shape anymore. Rather, it will go into the amorphous state. So that is what water of crystallization is about. Water of crystallization helps us to understand efflorescent, deliquescent, and hygroscopic substances. Efflorescent, deliquescent, and hygroscopic substances. So, what are efflorescent substances? Efflorescent substances are substances which, when exposed to air, loses part of their or all of their water of crystallization to the atmosphere. They are substances which when exposed to air, lose part of their water of crystallization or all of their water of crystallization to the atmosphere. An example is sodium trioxocarbonate 4, which actually is bound by 10 molecules of water as water of crystallization. When it is exposed to air, it loses 9 of its water of crystallization and it becomes it loses 9 of its water of crystallization and it becomes in a form of its own. Okay, let's talk about deliquescent substances. Deliquescent substances. Deliquescent substances are substances which, when exposed to air, absorb water from the environment until they become a solution. When they are exposed to air, they absorb water from the atmosphere until they become a solution. We have a number of substances which do this. Many of the chloride salts do this. Sodium hydroxide also does the same. When exposed to air, they absorb water until they become moist. Until they become moist. As they become a solution, not moist. They become a solution. Also, we have the hygroscopic substances. Hygroscopic substances. Hygroscopic substances also absorb moisture from the atmosphere, but unlike deliquescent substances, they do not become solutions. Rather, they only absorb enough to just get them a little wet, and they get moist and they just stop absorbing from the atmosphere. A good example is the tetraoxosulfate 6 acid. It gets moist and it stops absorbing water from the atmosphere. Alright, let's talk about ionic reactions and equations. Ionic reactions and equations. When we're talking about ionic reactions and equations, it means we're taking into consideration only half equation of the entire equation. We're taking into consideration only half equation of the entire equation. Alright, let's consider ionic reactions and equations. Of course, when atoms react, they react in forms of ions because they want to gain or lose electrons, or sometimes they just want to bond together in a covalent bond. So all of it is all about bonding. In this particular first equation shows the actual thing that is happening, while this lower one shows a view of a part of the expression we want to see. If we also want to draw the other half of the equation, I can also have Cl minus plus Na plus to produce NaCl. It's a way of of one to focus on what one wants to observe. For example, we know that in the neutralization process, that's the acid-base reaction, the main thing is the hydrogen ion reacting with the hydroxyl ion to produce the water. What the salt would be cannot be predetermined unless we know what chemicals, what acids and what bases are reacting with each other. So in this particular kind of thing, there are some things that should be kept at heart. The first thing is you do not dissociate gases. You do not dissociate gases. Apart from the fact that you do not dissociate gases, you do not dissociate certain liquids that are definitely going to be together, that you know will not react. You do not dissociate them. You leave them as they are. And of course, you take out the parts which is your main focus and you work them out. You make sure that there is a balance also in the power, in the charges. There is a balance in the charges. Minus plus, minus 1 plus 1 gives 0. Plus 1 minus 1 gives 0. There must be a balance in the charges that is being transferred. Let's quickly consider conductance of acids, bases and salts. Conductance of acids, bases and salts. Naturally, so pure water, that is clean water, perfectly clean water, it is not a conductor of electricity. It does not conduct electricity. But certain things can be inserted in distilled water to make it a very good conductor of electricity. For anything to be a conductor of electricity, it must possess certain electrons. It is these electrons that would carry the electricity from one point to another. Otherwise, it will not transfer any electricity. So, for us to achieve this, we can simply dissolve acids, bases, or some salts in the water. This automatically charges up the water and makes it ready to partake in a chemical reaction. And such chemical reaction can also be a conduction of electricity. So the conductance of acids, bases and salts can be tested when they are dissolved in water. Alright, in this lesson on acids, bases and salts, we talked about acids. We defined acids as substances which possess hydrogen ion or hydrozonium ion as the only positively charged ion in them. We talked about the basicity of an acid. We talked about the number of liberatable hydrogen in the system. We talked about the properties of acid as the physical and chemical properties of acids. We said acids are corrosive because in their concentrated form. Acids have sour taste and they turn blue litmus red. Also, we said that acids react with metals to produce liberate hydrogen gas. They react with bases to produce salt and water, and they react with tetraoxosulfate 6 of any kind to liberate carbon dioxide, that is carbon 4 oxide. Also, we talked about the neutralization. We talked about bases and alkalines. Bases are substances which possess hydroxyl ion as the only negatively charged ion when dissolved in water. So we also talked about alkalis being soluble bases that are soluble in water. We also made mention of properties of bases, that they are strong bases are corrosive, they have bitter taste, they have a soapy feeling when you touch them, and they turn red litmus blue. They turn red litmus to blue. Then we went on to talk about the measurement of acidity or alkalinity, or we talked about the pH scale, and we talked about the salts and their types. We have different types of salts. We have the normal salt, the acidic salt, the basic salts. We have the complex salts, we have the double salts. Also, we talked about water crystallization. Water crystallization talks about water that is absorbed by a particular salt to stay in its crystalline state. We talked about efflorescence, which is liberating, giving off of water. Deliquescence, which is absorbing moisture until it becomes a solution. We also talked about hygroscopic substances which absorb water just to become moist. And then we went into looking at the ionic equations or reactions, where we simply consider only half of the entire reaction, which is a part of it, which is our focus. We also talked about the conductance of acids, bases, and salts. That pure water, distilled water, cannot transmit electricity, but when any of these substances is dissolved in it, it becomes a good conductor of electricity. Good. In this lesson, we've learned so much. In a few seconds, some questions will be displayed on your screen to test your knowledge of what has been taught in this lesson. Please do well by answering them. And if there's any of the problems or any questions which is challenging to you, you can take the video one more time. Thank you.